Myself, Dr. R. Rekha, Assistant Professor of Statistics, Sri Sharda College for Women Autonomous, Salem. Now I'm going to talk about Newton's forward interpolation and Newton's backward interpolation formula. Interpolation is nothing but the process of computing intermediate value of a function from a given set of tabular values of the function, which means that the value of x for which the value of y is to be estimated is an intermediate value in the given set of values of x. Then the method of determining y is called interpolation. For example, here we have an example. Find the values of y at x equal to 21 and x equal to 28 from the following data. Where the values of x are 20, 23, 26 and 29, and the values of y, which is written as f of x, that is y is equal to f of x, are 0.3420, 0.3907, 0.4384 and 0.4848. First, now here they are asking us interpolate a value x equal to 21 which lies in the values of x, particularly in between 20 and 23. Now we have to interpolate the value of x, which means corresponding to the value of x. We have to find the value of y. So far, when x equals to 21, what is f of 21? So the method of determining f of 21 is finding the values of y for a given values of x is known as interpolation. Here, the dependent variable x is also known as argument, and the independent variable y is also known as entry. So, x is the argument and y is the entry. And there are several methods to obtain the interpolate value. Here, the few methods are first one, Newton's forward interpolation and Newton's backward interpolation, and also Lagrange's interpolation formula. So now, what is Newton's forward interpolation, backward interpolation, and how we have to identify the method and apply on the problem what we are going to learn. Now, the interpolation method, that is the value of x may be equally distant or may not be equal. That may be equal intervals and it may be unequal intervals. So, whenever the values of x are placed in equal intervals, we will be using either Newton's forward formula or Newton's backward interpolation formula. And whenever the values of x are placed in the unequal intervals, we will be using Lagrange's interpolation formula. And in that, how to identify Newton's forward interpolation or backward interpolation, it has to be applied. Here, if the value to be interpolate lies in the forward of the table when we use the forward interpolation formula, and if it is lies in the backward of the table, we will be using backward interpolation formula. So here in our problem, first one, find the values of y at x equal to 21. Here the value of x is lies in the forward of the table. So here we have to use the forward interpolation, Newton's forward interpolation formula. So the formula for Newton interpolation is y of x is equal to y naught plus u delta y naught plus u into u minus 1 divided by 2 factorial into delta square y naught plus u into u minus 1 into u minus 2 divided by 3 factorial, that is 6 into delta power 3 y naught plus etc. This is the general formula for Newton's forward interpolation. Here u is equal to x minus x naught divided by h. So for x value, here the x value is 21 and x naught value is 20 and x value is difference between the x naught and x1, which is equal to x2 and x1, which is equal to x3 and x2. So that is the difference between 23 and 20 is 3 and also 26 and 23 is 3. So the value of h is 3. So here the value of y naught is 0.3420 and this is the value of y1, this is the value of y2 and this is the value of y3. So this is the given values of y. So in our difference table, first we have to find out the delta y, delta square y and delta cube y. First we have to find out the first difference of y, that is delta y. So how to find the delta y? Just we subtract the y0 and y1, that is delta, the formula of first difference is delta y0, which is equal to y1 minus y0, the difference between y1 and y0. So 0.3907 minus 0.3420, which is equal to 0.0487. So which is the value of delta y0. And next we have to find out the delta y1, which is equal to y2 minus y1. So 0.4384 minus 0.3907. So which is equal to 0.0477. And we have to find out the delta y2. So that is the difference between y3 and y2. So 0.4848 minus 0.4384, which is equal to 0.0464. So these are the first differences of y. And next we have to find out the second differences of y. So which is denoted as delta square y. So first we have to find out the delta square y naught. The formula of second difference is delta y1 minus delta y naught. That is 0.0477 minus 0.0487, which is equal to minus 0.0010. And also find out the delta square y1. That is the difference between delta y2 and delta y3. That is the difference between delta y2 and delta y1, which is equal to 0.0464 minus 0.0477. So this is the second order difference of y. And the next one we have to find out the third order forward difference. The formula for the third order difference is delta cube y naught, which is equal to delta square y1 minus delta square y naught. That is the difference between these two things, minus 0.0013 minus and minus of 0.0010. So that we can get minus 0.0003. So this is the Newton's forward difference table. Here there are only 4 data given. So the polynomial will be of degree 3. So here we substitute all the values in Newton's forward interpolation formula. So here u value is 0.333 and y naught value is 0.3420 and delta y naught value is 0.0487 and delta square y naught is minus 0.0010 and delta cube y naught is minus 0.0003. So just to substitute these values in Newton's forward interpolation formula, we can the value of y at x equal to 21 is 0.3583. So this is the example of Newton's forward interpolation formula. Next one we go for Newton's backward interpolation formula. So here given that we find out the value y at x equal to 28. Here the value of x equal to 28 is lie in the backward of the table. So we have to use the backward interpolation formula. So first we form the difference table. Similarly, Newton's forward difference table. So here the formula for Newton's backward interpolation is y of x is equal to yn b delta yn plus b into b plus 1 divided by 2 delta square yn plus b into b plus 1 plus b plus 2 divided by 6, that is 3 factorial into delta cube yn plus etc. So here we have to use the backward operator, that is nebula. So here v is equal to x minus xn divided by h. So the value of x is 28 and the value of xn is 29. That is, we have to take the lowermost diagonal values in the backward difference table. So here h is equal to 3. So the value of v is minus 0.333. So already we know the value of delta yn, that is nebula yn. The value is 0.0464. So just we have to substitute all the values in Newton's backward interpolation formula. We can get The value of y at x equal to 28 is 0.46951. So this is the example of Newton's backward interpolation. So this is the book for reference.